Okay, hello everyone. My name is Bhushan Mahajan. I am pursuing my BE Sandeep Institute and Research Technology Nashik. This internship will be also provided EMERTXE Info Technologies Bengaluru. Okay, now let's move towards the content, the introduction first part, then feature, third requirements for IoT, fifth embedded system, sixth Arduino IDE, seventh Pixim lab, and eighth Blink IoT app, and nine project demonstrations. So this all about contents. Next moves to the introduction part. Home automation is the automatic control of electrical devices in your home. These devices are connected to the internet, which allows them to the control remotely. With home automation, devices can trigger one another, so you don't have to control them manually via an app or voice assistant. For example, you can put your lights on schedules so that they turn off when you normally go to sleep, or you can have your thermostat turn off the AC but AC up about an hour before you return to work, so you don't have the return to a safety house. Home automation makes life more convenient and can even save your money on heating, cooling, and electricity bills. Home automation can also lead to greater safety with Internet of Things devices like security camera and systems. So now let's move towards that. The first week I'm learning to the C and C++ language are basic. First week, some of the few basic covered from C language are first B basic syntax and data type, operators and arrays, functions and pointers, preprocessor header files, macros, storage classes, strings, and some of the few basic covered and C++ language are the basic syntax, classes and object, constructor and destructor. Now next forward, this is the Blink mobile app. This will be function to the Pixim lab to the cloud server and then mobile app and to the home. This is the home automation. So it will be to cover that all part in the screenshot. Let's move to next part. And the features of the home automation is the remote assist. Being able to control devices remotely means things like unlocking the door for a plant seater without having to leave a key under the mat. And then second will be comfort. You know, when you are all comfy in a bed but realize you have left the bathroom light on, with smart light bulbs you can turn them off from the comfort of your bed without having no leave those high thread count sheets. And third verse is energy efficiency. How many times have you left the heat on blast while you are out of the hours for 8 hours? With home automations, you can set things like thermostats on schedules to make sure you are not wasting energy. A study found that Nest thermostats in a particular can save about 12% on heating and cooling costs. For example, that means that over time, that smart thermostat can actually pay for themselves in saving. This is all about features, and this one is the IoT Internet of Things, the network of physical objects that contain embedded technology to communicate and interact with their internal state or the external environment. And the second word is the IoT makes dumb devices to the smarter by giving them the ability to send data over the internet, allowing the devices to communicate with people and other IoT enabled things. And third word is the smart home. The connected smart home is a good example of IoT in actions. Internet enabled thermostat doorbells, smoke detectors, and security alarms create a connected hub where data is shared between physical devices, and user can remotely control the things in that hub, that is adjusting the temperature setting, unlocking to the doors, etc. via the mobile app or website. This is known as the basic the basic and advanced part of Internet of Things. And the embedded system, to the next. Any combinations or the defined will be the embedded system. We learn that in this internship, any combination of hardware and software which is intended to perform a specific task, that task can be called as an embedded system. An embedded system is a combination of computer hardware and software designed for a specific function. Embedded system may also function with a larger system. Embedded system may also function within a larger system. The systems can be programmable or have a fixed functionality, such as the industrial machine, consumer electronics, agricultural and processing industry devices, automobiles, medical equipment, cameras, digital watches, household applications, appliances, airplanes, vending machines and toys, as well as mobile devices are possible location for an embedded system. And this will be Arduino IDE. The Arduino IDE means the Arduino Integrated Development Environment. This is known as the or Arduino software IDE contains text editor for writing code, a message area, a text console, a toolbar with buttons for command function, and a series to the of menus. It connects to the Arduino hardware and upload programs and communicate with them. It is an official Arduino software, making code compilation too easy that even a common person with no prior technical knowledge can get their feet wet with the learning process to the Arduino IDE. And next part will be covered. This is the Arduino IDE. This is the Arduino versions. This is the Arduino IDE version. This is the menu bar. I am taking to the screenshot to show about the status, show the uploading status, error message. This will be sorry to compile the message. We get to the void setup, and which also shown by the error message. Configured the board and serial port. So this is the text editor for writing code, and this is the toolbar button, and this is the file name. This is all about Arduino IDE path. Okay, let's move forward. Pixim Lab. Pixim Lab is a real-time emulator. This is emulator of development boards within an integrated MPLABX, uh, AVR, GDB debugger, and the Pixim Lab supports some microcontroller from Pixim, some from Simaware, and some from UCSIM. And Pixim Lab have an integration with the MPLAB X Arduino IDE for programming the board's microcontrollers. As the purpose of Pixim Lab is to emulate real hardware, it does not have any source code editing support for code editing and debugging, and the same tool used for a real board should be used with a Pixim Lab such as the MPLAB X and Arduino IDE. The Pixim Lab. And next one, Blink IoT app. I am taking two screenshot to show the everyone. Blink was designed for the Internet of Things. It can control hardware remotely. It can display sensor data. It can store data, visualize it, and do many other cool things to like the Blink IoT map. It is the home automations to the device to the notify all water volume, heater button, etc. And this is the developer mode. Okay, so we functioning all about the project. We build the project successfully by writing multiple lines of code on a Arduino using Pixim Lab simulation. In our IoT home automation system, we include controlling garden lights that function on LDR sensor and the intensity of light dependent of the amount of sunlight received. If was no sunlight, the LEDs will switch on, and if there was a good amount of sunlight, the LEDs will go off. Next, we control temperature system, including heater and cooler, which will function sensing the temperature around. If the temperature will rise above 35 degree Celsius, the heater will turn off automatically, and we will receive a notification on our Blink app that the heater is turned off. Finally, we control the water tank system where we had inlet and outlet value If the water level of tank goes below 2000 liters, we'll also receive notification on our blink app that the water level is below 2000 liters and the inlet value will be automatically turned on. So this functioning all about the project home automation. So demonstrations, and also I get to the project screenshot. This is the temperature. This is the temperature. This is the volume in inlet flow on. This is the ISIS part. This is the Ethernet. This is the LDR, and this is the LED, and this is the cooler. Say LDR. This is the garden light LCD. I am taking two screenshot to show that. Okay, the Pixim lab is a spare part. Okay, now shown. Okay, this is the okay. Other this is the serial remote tank. Is to the serial port communication to the connect to the port. Here will be COM1 to the here will be COM4 to the connect each other to the virtual pin, and to the reset button it will be turned on, so the automatically get serial remote tank on, so the gate will be notified in blink RT app. Okay, this is the project of demonstration of home automation. Show that the next. Okay, this is the mic. I am capturing my screenshot from mobile app to the blink RT app. This is the temperature and heater. The temperature is greater than 35 to the turning of the heater. Temperature is greater than 35 to turning of the heater. I mean the temperature is greater than 35 to the turn of the always, of course, the turning of the heater. And second one is second screenshot to shown that the water second and third to the water level is 2000 up to 2000 1960 to 2000. The water level is less than 2000. Water inflow enabled to the get notified to the blink RT app as you shown. Okay. And finally, the conclusion. Finally concluding, I would like to thank EMERTXE for making this project successful. We were able to build IoT-based home automation system and control it using to the Blink app. This all about project home automation system. This is PPT. Thank you, everyone. Thank you. Okay, so this is the Arduino Uno IDE. Here we saw like the screenshot in previous part. Now to showing to controlling the blink LED Ethernet also. So that is typically first we all require to the header file, and libraries are to included such include SPI, Ethernet, Blink, Ethernet, Liquid Crystal, main.h, temperature system, all about that. And now with the set the LCD address 0827 a 16 character 2-line display. This is the pin 1, this is the 0 stage virtual pin, cooler V pin to parameter, INT to on color on the sorry cooler on. If the else if else is condition is just reprogramming like, and to turn on and off heater virtual pin value to the parameter which on to the heater will be on, and the parameter will be off, the heater control be off. This is to turn off and on and off inlet value base virtual pin value. Blink right to the parameter. This is 7 1 in flow on flow off. This is parameter. Okay, and this is the temperature value of Gauge on blink app. The blink app is specified to the temperature plot less than to 35. The temperature is above 35 degrees Celsius is turning off to the heater, and will be 2000. The water volume is less than 2000. The turning on the inlet value will be on, and then the tank volume is 3000. The water volume is full. The turning of the inlet value automatically. This is the setup of void. This is the LCD black backlight. Clear the screen, And cursor to the home, the temperature system T is equal to V is equal to the tank 500 liter temperature reading. That's all about that home automation. And then now LDR CPP. LDR CPP is a brightness control method to the help of LDR with the help. And okay, the this is the LDR CPP, all about that. This is a one shot. This is the LDR.h. LDR, this is a Microsoft LDR sensor we use to also define the method. And the main.h, it is used to do all the macros of the program. So it is a temperature, cooler, heater, water, inlet, outlet, blink, terminal. And the serial tank CPP, it will declare how much value is tank pool, or tank will be tank pool or not. This is this is the typical. And serial tanks tank dot cpp is just like program that. And serial tank dot h, this all method of macros, the header file over here, all macros are over file header are here. This is the okay. And then temperature system dot cpp, temperature system dot cpp, the cooler, this is this is the now the cooler control, which means value is the machine off and on to the LCD this temperature to convert to the degree Celsius, it's known as. And temperature all temperature system dot h, last we see the temperature system dot h, all the declaring method names, like this is all the declaring method name and macros. Okay, I will see that the Arduino program. Okay, Pixim lab. This is the Pixim lab temperature volume. This is the LDR LED Ethernet fan, and this IC will be used there. So the okay, let's we see that. Can okay, firstly I will started. Firstly I will start it to do, and then to file load X. I am early to fetch that. Okay, load X. So I am not given to to load X. I am already used to the automation. Not okay, not defined at okay lab, and then water volume, and get connected to my blink RTF in mobile. Just blink. I'm clicking to power mirror. And then okay, start now. I'm connecting the blink RTI. This will be offline. So the reset I am press. It will be online. Can I show this? This will be online. And now I am getting to show the tank system. Okay, I turn on the outlet value, it will be the turn on. It's when the off of the outlet value is to be the turn off. Okay, fine. connect, and then my Ethernet. That's so tank is not okay. Tank is will be connect, and you can see that also. Tab 2. You see that this is the volume will be increased and any flow will be on. The turn on the outlet value is become to the 2000 is turn out to be the inlet value. You get notification to the mobile application. Okay, you get the water volume is full, turning off the inlet value. It is now, and we clear the first implemented the project demonstration of water tank. So okay. Secondly, I am trying to just 1 minute. Secondly, I am trying to the temperature system. Okay, there is the heater. Okay, the temperature it is heater is 13.18. So the temperature is also the screen CLCD. This is also the screen CLCD. Also that heater will be off automatically. The second will be implemented to the heater. Okay, it shown that the power mirror also. Sorry. It is also shown water volume is full. The turning of the it is the first demonstration project. The water volume and second will be the temperature is about 35 degrees Celsius. Turning of the heater. So that's two pack and also we be include now sim lab. So I am turning the home automation. I am turning the cooler and their cooler will start. This is the screen will be shown. The screen not show cooler will be automatically turn on the button and cooler will be on, and also with the off the cooler will be off, and then the temperature will be increase not a increase. This is the on conditions. It's like on condition, and it will be off condition. Okay. So and next to be the fourth implement is the Ethernet. This is the Ethernet. So line will be blink to the reset option, and fourth one is the LDR system. You can show also. Okay. Okay. And then this is the temperature light. It is also reduced. Okay. The garden light will be the reduce. Okay. The if the okay to the last to the controlling to the garden light if the register is less availability to the in sunlight to the LCD will also off to the LDR system to connected. So LDR starting to increasing to the brightness. LDR increasing to the brightness to start will be decreasing. Okay, the decreasing it's also decreasing and it's also increasing. Sorry. Okay, there's the project demonstration. Thank you everyone. And lastly, we to seen that this home automation is connected. I am getting to the heater will be on. Heater will be on. It will show that heater will be on. The temperature will automatically do the down so that temperature is above 35 degrees Celsius. Turning off the heater. Okay, that's the project our we implementations. Thank you, emergency. And lastly, we connect to disconnect and connect. Okay, and to the reset button. Okay, reset button. It will be turned automatically. Okay, the water will be flow on. Okay, the water will be flow on. To show. Okay, okay, sorry guys. Water volume is less than 2000, the turning on the inlet value. It will be inlet value to generate. So if the turn on outlet value, it's also be to 3000 full. And then okay, okay, tap to okay, automatically full. And that each turn on the outlet value, it become to the 3000 each turn, and to the inlet value to the get notification on mobile application. So the power mirror to connected the, and this project will be implemented. So thank you guys, you hearing me. This is our to the for this is our fourth part of implementation. First will be to generated garden light. Second will be second will be generated our no, first we implemented our serial remote tank. Second will be implement that the heater turn on or off, and then garden then cooler also will be off and on condition, and then this is the garden light can be also increase or decrease. That's my project. Thank you, emergency, for this great opportunity to me. I am